Alright, welcome to a helpful video. This time it came in on section 7.2. There's a question about problem number 3 through 10. So let's just look at number 3. It says find the z-score such that the area under the standard normal curve to the left is 0.25. So that is that's as basic as it can get. Let's pull up this on the chart here. So if we have the standard normal distribution, that means we have this and it's standardized, so the mean is 0, and every deviation or every z-score is here we have -1 and 1. They're in terms of 1. Okay, now what we need to do is find the z-score such that the area to the left is 25% of the entire thing. So let's just say about here. I'm not sure if that's 25% or not, approximately. And so this line here, what we want to know is what is that z-score? What is that that's going to give us, that separate the lowest 25% from the upper 75 for the rest. And in order to do this, we use what's called the inverse norm on the calculator. The inverse norm gives us the z-scores when we give them the area. So I mean, like, one could just do inverse norm of 0.25, and it gives you, so inverse norm works when you have the area to the left. Now if they gave us the area to the right, we'd have to figure out, well, what's the one to the left, and that's the one we plug in. But for this problem, it's really straightforward. Let's look at our calculator here. I'm going to bring this over. So you go to distribute, second distribute, and you see inverse norm is number 3. It's the area to the left. The mean is 0. The standard deviation is 1 because it's standardized. And that's what you get. Okay, negative 0.67. If I do a second entry and I were to delete all that other stuff, so we simply just do not need it, you get the z-score. Alright, z-scores are usually rounded to the nearest hundredth, so that'd be negative 0.67. That works. Now, we could have also used StatCrunch. There's a calculator in StatCrunch. Hopefully my StatCrunch actually will work. Okay, it did. Good. And we go over to calculators, and what we need is the normal calculator. And I have to give them the area to the left. So the area to the left is 0.25. And the way you interpret this, again, by default, the mean is 0, deviation 1, because it is the standard normal. And you put in the area, which is the probability of all the x values less than this will actually be 0.25%, less than or equal to this score. So in other words, negative 0.67 is right there. Our sketch was pretty good. Our sketch on our, I thought that was really good, because yeah, that was about 25% of the whole entire thing. All right, let's look at some more. They can get extremely tricky. Why didn't it just boot me to the next problem? I don't get it. It says assume the probability of the binomial random variable will be approximately using the normal distribution. Describe the area under the normal curve that will be computed. Find the probability that there are exactly 7 defective parts in a shipment. Okay, so the question is as well, what is the area under the normal curve that describes the probability that there are exactly 7 defective parts in the shipment? So this looks like more of a conceptual question, and we're talking defective parts in the shipment. There's so you do have to know a little bit about um, the rule for approximating a binomial random variable. The truth is that we don't have to approximate it because we actually do this section, binomial distribution. But here they want you to be able to approximate it, and these are the different choices. All right. I think my gut is leaning towards E, but what I would recommend first is going back and just quickly reviewing um, the 7.2 approximating normal distributions real quick. So we'll go here, we'll pull up the notes, we'll scroll down to 7.2, and let's make sure that we are finding, that's 7.3, so let's get back to 7.2. Oh, there's 7.2. And let's take a look at approximating a binomial using the normals bell-shaped. Okay, here we go. It's a 7. It's actually 7. The normal approximation to the binomial probability distribution. Let's see if they actually give an example of this or not. That wasn't it. Alright. Yeah, it looks like they did not give us any info on this. Which makes me think that maybe that particular question isn't really a 7.2 kind of question, because we're talking about 7.2 applications of normal distribution, and they want us to approximate the binomial, which comes from another section. So let me double check something here. Let's check 7.2. Hopefully it is the same that we're discussing here. Um, yeah, they're only talking about normal random variable, not the binomial random variable. But in 7.4, it looks like they do talk about it. So it looks like that question is from 7.4. So it's kind of a one-off. I'll remove. That question's not going to come up. Let's see. Okay, here we go. So this one, 7.4 is dealing with approximating the binomial probabilities using the normal distribution. And here's what they're saying. If you're looking for the exact amount, then it will be the left and the right values of it. So this is that chart that this is like the cheat sheet. Yeah, this is the cheat sheet for it. In other words, if you're looking for the probability of exactly 7, then that will be, you can approximate it by 6.5 and 7.5. So x will be between that, and whatever you get for that probability, that's going to be the exact value for that. The others, you're going to take plus 5 and everything less. If it's greater than a, you'll subtract the 0.5 and take everything else. But so basically, you're giving yourself a 0.5 margin, plus or minus, between them all, and that's how it's pretty much done. So going back to that question, just one second. Yeah. Let's go back to 7.2. Number 4. So find the z-score. Find the z-score to the area to the right of 0.42. That's not the exact one that we just had, but we could probably do this one anyway. Let me go back. There's that one. That one. Yeah, the one about the binomial formula is gone now. So weird. So here is find the z-score such that the area under the standard curve to the right is 0.42. So for this one we would do, unless I just clicked on the wrong thing. Maybe that's what I did. So this is the area of 0.42 approximately, which basically means the area of the rest will be 0.58. So all we got to do is just inverse norm of 0.58, and that's going to give us this z-score right here. So this z-score separates the upper 42% from the lower 58%, from the left 58, right 42, because together that makes 100%. So that's what you would do for that one. We can come in here, we can do, again, inverse norm of 58. We're getting 0.20, 0.20. Yeah, something tells me it was 7.4. All right, this is everything greater than 41, so that would be C. What is the probability there? Well, what we would do is do the normal CDF this time, since we have the bounds and we need the area. So we're going to do, the lower bound is 41 and the upper bound is unbounded. So let's do that. We're going to go normal CDF, (41). The upper bound, let's just put in a very large number. Sometimes what people do is put in 1 e to the 99, or even 9 e to the 99 for that matter. Doesn't matter. The mean is, this is not the standard normal distribution. The mean is 50 and the deviation is 7. Point 90. They want 4 decimal places, so 9007. And again, StatCrunch would have been able to do this. You'd simply go back into StatCrunch. You would put in what the mean was, what the deviation was, and then put in the value. If it's between, you click between. But it was actually like 41 and greater. So we were here. It was like that. The mean was like, let's see, I don't remember. The mean was 50, the deviation was 77. So let's do, and then when you hit compute, it gives you what we got. So yeah, I mean, you really have to be comfortable doing these kind of problems like that. Let's look at 7. Assume the random the mean is 45, deviation 10, compute the 55 through 70. So the one in between, that's going to be here. And then what is that probability? Well, I mean, I could just put that in, put in what we just had, second entry, put in my lower bound, my upper bound, and all those values. Just change it around. Again, my lower bound 55, 70. My mean 45, deviation 10. Has to be in this order. I'm getting 1524. The 78th percentile. So this is an example of this would basically mean the 78th percentile. That means everything to the left is 78%. So we're looking for the z-score. Actually, not the z-score. Well, it is the z-score, but this is not the standard normal distribution. The mean and the deviation is not 0 and 1 this time. They gave it to us. The mean is 50 and the deviation is 7. So this is an inverse norm because we have the area 78%, the area to the left. And so this time what we're going to do is go back in the inverse norm, second distribute, number 3, and it's 0.78, the 78th percentile, 50 and 7, and that is to the left. And that's 55.41 when we round it off. So yeah, it's not too bad. This one I think was demonstrated in another video. Let's look at 10. And this one, I'm going to leave you to work on this one. Draw a relative frequency. Well, guess what? You can open this data in StatCrunch. And from there, you can graph it exactly the way they want you to graph it. Create a histogram where the first class is 310 and class width is 20. Describe the distribution. So I would do, by the way, we are going to create a graph, a histogram based on the sample distance starting at, does it say 310 with a width of 310 with a width of 20. Just graph it. You must select the column. I never selected the column. There's the column is now selected. And that's a normal distribution. That is symmetrical. It looks good. No, that wasn't it. Well, kind of, but I want to see some more. That one looks like the other one. No. No way. No way. I actually like B. I don't know. I'll just pick one. Okay. Well, maybe A. Okay. Yeah. I mean, that's the distribution appears to be bell-shaped, and the mean was right smack in the middle of our shape. So, and the deviation, we could figure that out based on the shape too. In fact, we can take that same data and calculate these values in StatCrunch. It'd be pretty easy for us to do that. Alright, so I'm going to wrap up this video here, but if we go back to 7.4, because I think that's where the question was. And actually, 7.4 might not even be part of. You might not even have to do 7.4. Yeah, so it was between 7.5 and 6.4 and 7.5. That was the one. Alright, so that's going to do it for now.